Hello community! This is an outlook for the next 2 to 3 weeks on my channel. If you have your data in a graph format like in vision, chemistry, biology, let's utilize the benefits of graph neural networks. If you are interested to learn graph neural networks, those 3 videos here in yellow and blue I would highly recommend. It is also suitable for beginners to start with the left video, then go to the video on the right side, and then the video in the middle with the JupyterLab Python code implementation. You will learn the basic on knowledge graph. If you want to dive deeper, here are my videos on GNNs. Please start with the red video, the red envelope video in the bottom line, Graph Convolutional Network. It shows you the transition from convolution networks to graph convolution networks if you want to understand why and how it happened in 2016. You find a lot of videos on graph neural networks implementation either in pure Keras code, in PyTorch geometric, or I recommend Deep Graph Library for the code implementation. You see I have videos on JAX and implementation of graph neural networks in JAX if you want to optimize your performance. And in the line you see symmetry and representational learning in red. Those 2 videos are theory videos I highly recommend if you want to go into graph representational learning. Now you might ask, what is it? And it is easy. We want to learn the embeddings in a topological space for graph nodes. And then these embeddings, this presentation, this representation, we can use for our downstream machine learning tasks. Clustering, node classification, and link prediction. You see here a knowledge graph with different types of node and different types of edges or relation. If all have the same kind of node and the same type of relation, we call it a homogeneous graph. And here you see the link prediction test results of an homogeneous graph. 3 classes identified: path-based, embeddings, and GNN. With embeddings, there's a video upcoming on Node2Vec. This is node embedding class. I will do it in a pure Keras code in a COLAB notebook, so you can follow along if you want. As you can see here on the right side, I have an example with the Higgs boson, quantum symmetry, gluon quark plasma, and I show you how to utilize Node2Vec. A simple, scalable technology for learning low-dimensional embeddings for a node in a graph by optimizing the neighborhood-preserving objective. So the local neighborhood structure of nodes in a graph, the subgraph, will be encoded. I had done a video on tokenizer, BERT. This is the thumbnail for this video. And the same, what we did for the BERT, the transformer model, I have a video upcoming on NodePiece. It does the identical on a graph neural network. We optimize the vocabulary if you want. It's a little bit on the complicated theoretical side, but if you really want to touch the bleeding edge, I think my 3rd video that's currently in the making on the neural Bellman-Ford algorithm that operates on homogeneous graphs and knowledge graphs with the code implementation. This is really a little bit mind-boggling, but I will try my best to make it simple and explainable to you so you can jumpstart from where I leave off. Thank you for listening, and I will see you in the next video.